IPv6 neighbor discovery. Addressing table, RTA router, PCA1, PCA2, PCB1, PCA1, PCA2, PCB1. IPv6 neighbor discovery local network. You will obtain the MAC address of a destination device on the same network. Check the router for any neighbors that it discovered. Click RTA router, click here. Okay, show IPv6 neighbors on privileged exec mode. Okay, enter. Access privileged exec mode with enable command. Show IPv6 neighbor. Okay, and in my case, no entries. If there are any entries displayed, remove them using the command clear IPv6 neighbors. Okay, in my case, no entries. But anyway, use clear IPv6 neighbors. Clear IPv6 neighbors. Okay, and PCA1 command prompt. PCA1, click here, command prompt. Switch to simulation mode, click here. Show or none button, show or none button, this button. Make certain event list filters, visible events displays none. Okay, event list filters, visible events none. From command prompt on PCA1, use this command. Okay, click here PCA1 and use ping. Only one ping, option N, only one, and destination 2001, DBA, ACAD, 1: B. Okay, this will start the process of pinning PCA2. Okay, enter, don't forget enter. Okay, and now you will see this. And this is the ping from PCA1 to PCA2. Click capture forward button. Okay, click here, this button. Capture then forward, this button, click here. The status bar above the play controls should read captured to 150. Okay, 150, very good. Edit filters, IPv6 tab, IPv6 tab, ICMPv6 and NDP, ICMPv6 and NDP. Select both and close this window. And you will see this. Why are ND PDUs present? Okay, these green PDUs are the ND PDUs. In order to send packets from PCA1 to PCA2, PCA1 needs to know the MAC address of the destination. IPv6 ND requests this information on the network. Click the square in the type column for the first event, which should be ICMPv6. Okay, click here, the first ICMPv6, and this blue square, click here. Because the message starts with this event, there is only an outbound PDU. Under the IOSI model tab, what is the message type listed for ICMPv6? Okay, only outliers column. Okay, and look at this message type 128. This is the ICMPv6 echo. Okay, ICMPv6 echo message type 128. Notice there is no layer 2 addressing. Click next layer. Okay, now click here and you are on layer 3 and no information for layer 2. Click on next layer. Okay, now is layer 2. And on layer 2, okay, ND for neighbor discovery. The ND process looks it up in the neighbor table. The NDP process sends a neighbor solicitation for that IP address and buffers this packet. Okay, NDP neighbor discovery protocol. Okay, now click the next, the square next to the next event in the simulation panel. Okay, close this. Okay, close this. Okay, click the square next to the next event in simulation panel. Okay, this is simulation panel. It should be a device PCA1 and the type should be NDP. Okay, PCA1 NDP. Click here on this NDP square. What changed in the layer 3 addressing? Look at this. The ICMPv6 neighbor message type 135 and the destination IP address starts with FF02. And this is a multicast IPv6 address. What layer 2 addresses are shown? Okay, the source MAC address is 001 00014278 E8ED. Okay, this is the source, the MAC address of PCA1. But the destination MAC address is 3333 FF00000B. And this destination MAC address is a multicast address for layer 2. Okay, when a host does not know the MAC address of the destination, a special multicast MAC address is used by IPv6 neighbor discovery as the layer 2 destination address. Select the first NDP event at switch A. Okay, close this. Look at this add device switch A. Click here NDP. Switch A NDP is the third square, the third PDU. Click here. Is there any difference between the in layers and out layers for layer 2? Okay, layer 2, the source MAC address, destination MAC address, the switch does not alter the layer 2 information. It only forwards the frame. Okay, close this and select the first NDP event at PCA2. Okay, look at this PCA2 NDP. Okay, the fourth PDU, PCA2 NDP, click here. Outbound PDU details. Okay, this tab, outbound PDU details. What addresses are displayed for the following? Okay, Ethernet 2 destination address, Ethernet 2 source address. Okay, destination address for Ethernet 2 0001 427E8ED. Okay, source address 004 0B D2 243E. IPv6 source, IPv6 destination, IPv6 source 2001 DB8 ACAD1 colon colon B, and destination 2001 DB8 ACAD1 colon colon A. So for destination MAC address is the MAC address of PCA1, and destination IP, the IPv6 address of PCA1, source address, the MAC address of PCA2, and source IPv6 is the IPv6 address of PCA2. And obviously this is the close this PDU is placed on PCA2, okay, on PCA2. Select the first NDP event at RTA. Okay, now RTA, this NDP, click here. Why are no outliers? Okay, no outliers. Okay, the answer is the IPv6 address does not match the address of the router, so it drops the packet. And next layer, okay, click here, next layer. Okay, now you are on layer 2. Okay, next layer again. Okay, or simply click here on layer 3, and you can see all this, and you can see the packet is an NDP packet, Network Discovery Protocol packet. The device processes the packet. The ND packet is network solicitation. The network solicitation's target IPv6 address does not match the receiving port's IPv6 address. The NDP process drops the packet. Click next ICMPv6 event at PCA. Okay, close this. PCA ICMPv6, this square. PCA ICMPv6. Click here. Those PCA now have all the necessary information to communicate with PCA2. Okay, on layer 3, IPv6 source address, destination, very good. And on layer 2, the source address is 0001427E8ED, the MAC address of PCA1, and the destination MAC address is 00400BD2 243E, the MAC address of PCA2. So the answer is yes. Okay, so PCA1 knows the destination IPv6 address and the destination MAC address. Click the last ICMPv6 event at PCA1. Okay, close this. This PCA1 ICMPv6, the last, click here. What is the ICMPv6 EUCO message type? Okay, look at here. ICMPv6 EUCO message type is 129. Okay, 129 is the echo replay. 129 echo replay. Reset simulation. Okay, close this. Close this. Reset simulation. Click here, reset simulation. And from the command prompt of PCA1, repeat the ping. Okay, click here on PCA1. Repeat the ping, enter. Click capture forward 5 times. Okay. Click on this button, capture then forward 1. Click again 2. Click again 3. Click again 4. Okay. Click again. Okay. Why weren't there any NDP events? Okay, PC1 already knows the MAC address of PCA2, so it doesn't need the neighbor discovery. IPv6 neighbor discovery remote network. You will perform steps that are similar to those in part 1, except in this case the destination host is on another LAN. Capture events for remote communication. Display and clear any entries in the IPv6 neighbor device table. Okay, and go to real time. Go to RTA. Show IPv6 neighbors. Clear IPv6 neighbors. And simulation mode. Click here, simulation. Show all none. Click here, show all none. Okay, none. Okay, none is displayed. And command prompt PCA1 ping to this address. Ping only one ping 2001 DBA ACAD 2 colon A. Okay, is the ping to host PCB1. From PCA1 ping to PCB1. Enter. Capture forward. Click here. Capture then forward. Click here. Okay, and 150. Edit filters. Click here. ICMP tab. Select ICMPv6 NDP and close the window. Now you will see all these PDUs. You should notice there are considerably more entries listed this time. Click the square and type column for the first event. Should be ICMPv6. Okay, the first is this ICMPv6. The first on the top ICMPv6. Click here. Notice that it is missing the layer 2 information as it did in the previous scenario. Okay, no layer 2 information. First NDP, PCA1, close this. PCA1, NDP, click here. What address is being used for the source IP in the inbound PDU? Okay, the source IP on layer 3 information starts with FE80 column. This is a link local address. Is the link local address of PCA1. IPv6 network discovery will determine the next destination to forward the ICMPv6 message. Okay, second ICMPv6 event for PCA1. Okay, close this. This is the second PCA1. This is the first PCA1. This is the second ICMPv6. Okay, click here. PCA1 now has enough information to create the ICMPv6 EUCO request. Okay, now on layer 3 has the source IP, the destination IP. Okay, this the IP for PCA1 and the IP for PCB1. And on layer 2, the source MAC address and destination MAC address. The source MAC address is the MAC address of PCA1 and uses this destination MAC address 00196.1d6301. What MAC address is being used for destination MAC address? Okay, is the MAC address of gigabit interface on router RTA. Okay, the gigabit interface on router RTA on this site. Click next ICMP v6 event device RTA. Okay, click close this. ICMPv6 RTA ICMPv6. Okay, click here. Notice that the outbound PDU from RTA lacks the destination layer 2 address. Okay, go to outliers and layer 2. Okay, and outliers, no information on layer 2. This means that RTA once again has to perform a network discovery for the interface that has the 2001 db8 ACAD 2 column network because it doesn't know the MAC address of the device on gigabit 001 LAN. Okay, on this LAN. Skip down to the first ICMPv6 event for device PCB1. Okay, close this. PCB1 ICMPv6. Click here. What is missing in the outbound layer 2 information? Okay, outliers layer 2, no information. The destination MAC address is missing. The next few NDP events are associating the remaining IPv6 addresses to MAC addresses. The previous NDP events associated MAC addresses with link local addresses. Skip to the last set of ICMPv6 events and notice that all the addresses have been learned. Okay, close this. Go down here, and the required information is now known. So PCB1 can send echo replay message to PCA1. Okay, for example, click here on PCA1, ICMPv6, the last. Now you have the source IP and destination IP, and source MAC address and destination MAC address. Okay, and click reset simulation. Reset simulation. From command prompt on PCA, repeat the command to PCB1. Okay, go to PCA1, repeat the command ping to PCB1, 2 : A, enter. Click capture forward. Okay, capture forward, capture forward, capture forward, and click again, 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 and again. Okay, ready. Were there any NDP events? No, no NDP PDUs, no NDP events. Click only PCB1 event in the new list. Okay, this is the only PCB1 event. PCB1 ICMPv6, click here. What does the destination MAC address correspond to? Okay, the source MAC address is this 0060-2F689E91 is the MAC address of PCB1, but the destination MAC address 000196-1D6302 is the MAC address of gigabit interface on RTA on this side, on the PCB1 side. Okay, the gigabit interface on RTA router. Why is PCB1 using the router interface MAC address to make its ICMP PDUs? Because the destination device is in another network. PCB1 addresses the PDU to the default gateway MAC address. RTA will determine how to address the PDU at layer 2 to send it towards its destination. Examine router outputs and return to real time. Okay, close this, real time, RTA, show IPv6 neighbors. And you can see this, how many addresses are listed. Okay, 1, 2, 3, 4 addresses. Global unicast address of PCA1 and MAC address of PCA1. Global unicast address of PCB1 and MAC address of PCB1. Link local address of PCA1, MAC address of PCA1. Link local address of PCB1, MAC address of PCB1. What devices are these addresses associated with? PCA1 and PCB1. Okay, PCA1, PCB1, PCA1, PCB1. Are any entries for PCA2 listed? Why or why not? PCA2 has not communicated across the network yet. Ping PCA2 from the router. Okay, ping PCA2 is 2001 DB8 ACAD1 : B. Enter. Success. Show IPv6 neighbors. Show IPv6 neighbors. Are Are there any entries for PCA2? Okay, this is PCA2. Yes, this is the entry. Global unicast address and MAC address for PCA2. Reflection. When does a device require the IPv6 neighbor discovery process? When the destination MAC address is not known. This process is similar to ARP on IPv4. How does a router help to minimize the amount of IPv6 neighbor discovery traffic on a network? The router keeps neighbor tables so that it doesn't need to initiate neighbor discovery for every destination host. How does IPv6 minimize the impact of the neighbor discovery process on the network hosts? It uses multicast addresses so that only a handful of addresses would be listening to the neighbor discovery messages. IPv6 creates a crafted multicast destination MAC address, which includes a portion of the node address. How does the neighbor discovery process differ when a destination host is on the same LAN and when it is on a remote LAN? When the host is placed on the same LAN segment, only the host that matches the IPv6 address responds to the message. Other devices drop the packet. When the host is placed on another network, the gateway device router provides the MAC address and then searches for the MAC address on the remote network. The router will then place the responding IPv6 MAC address pair in the IPv6 neighbor table, similar to ARP table on IPv4. Okay, thank you very much.